All right, ladies and gentlemen, welcome back. The last couple of lessons we've been looking at right triangle trigonometry. In other words, trying to find missing sides and missing angles in right triangles given some information like other sides and angles. Today we're going to look at how to do that, but not necessarily with right triangles. We're going to look at how to do that, find missing sides and missing angles with triangles that are not right triangles. For these warm-up problems here, you might notice on the left-hand side it's a normal right triangle. If you want to find a missing side, like the adjacent side, you have the hypotenuse already. You can ask yourself adjacent hypotenuse, that's going to be a cosine, and you can use cosine to solve that. If you're having trouble with that, look at some of the previous videos, particularly section 8.2 to find some missing sides. With number 2, though, we do not have a right triangle. We have a 39-degree angle, certainly, and we have an 88-degree angle, but neither of these are going to be 90-degree angles, and that leaves angle P to be significantly less than 90. So what do we do? What we're going to do is employ something called law of sines in this tutorial here, and then law of cosines in next time's video. Law of sines plain and simply says that you can take the ratio, remember a ratio is a fraction, you can take the ratio of a sine of an angle and the side opposite that angle, and that's equal to the ratio of the sine of any other angle and the side opposite that angle. For example, I want you to note about the lettering, that all letters are used, the same letters are used for opposite sides and angles. In this diagram here, we have side A right here. Oh, let me highlight that. Side A here, opposite angle A. Similarly, side C over here is opposite angle C, and side B over here is opposite angle B. The same letter is always going to be opposite each other, and then you can plug those values into the law of sines equation. For example, if you go ahead and look at this first triangle here, we have two angles and one side. If we want to label our sides, here's big angle D up top, so I'm going to label this little lowercase d side here. Angle E, that means lowercase e is going to be over here, and angle F is down here, so lowercase f is going to be up here. If we want to set up a law of sines equation then, I notice that we do have angle D and side D. We're going to incorporate that in our equation here. Sine of angle D over side D. And we can also do the same type of thing with angle, let's see here, we want to know FD, we want to know this side here, and we have the angle opposite it. So we could say then that that's equal to sine of angle E over side E. Plugging those values in now, we could say that's really sine of 105 degrees over 18. I'm getting those from the angle D and side D, is equal to sine up top, sine of 32 degrees over side E. We don't know what side E is yet, but we can solve for that. I'm going to go ahead and plug these values into my calculator now. Typing in sine of 105, I end up getting a 0.966 or so, 0.966. Let's go and type that out. 0.966 over 18. And that is going to be equal to, let's see here, sine of 32, typing in sine 32 in my calculator, if you could do that with me there. 0.53 approximately, 0.5299. We'll round that off to 0.53. over our E value. From here, it's a simple matter of cross-multiplying and dividing. We're going to cross-multiply these. We're going to cross-multiply these two. So I'm going to take 18 multiplied by 0.53. 18 multiplied by 0.053, or 0.53 rather, 0.53 gives us a 9.54. That means that 9.54 is equal to 0.966 e's. Dividing both sides by 0.966. That's going to leave us with a 9.88, I'll round, 9.88. We could say that E then is a 9.88. We do not have units here, but I can go and draw an arrow. 9.88. Always ask yourself, does that seem reasonable? If this side is 18 in length, this side looks like it's about half the size or so, and the side is also 9.88 in length, so that seems pretty reasonable. I'll leave this next one up to you. It's the same as the warm-up problem here. You can find the missing angle. I'll help you set this up real quick here. You could do something like sine of 39 degrees over the 22 side because they are opposites each other. This angle and this side are opposites each other. If you want to find NP on the bottom, we don't know how big NP is yet. We can go ahead and set that equal to the, I'll switch over to a fun color, let's say green. Sine of 88 degrees over the NP side that we don't know. Here's another one where you can just go ahead and cross multiply, divide that out after you plug in sine 39 and sine 88 in your calculators. You can also find angles with this law of sines equation. If we're given a couple of sides and we want to find an angle like angle S, I'm going to start out by labeling all my sides. Alright, here's little s, opposite angle S. Here is little t, right up here, opposite angle T. And angle R, side R, we don't know either of those pieces, so we're just going to ignore that for now. I'm going to go ahead and write a law of sines equation now, sine of 75 degrees over our side T. So here's our angle T and side T, put those together. And on the other one, we don't know how big angle S is, but we do know the opposite side is 5, so we can write that out. From here, we can go ahead and cross multiply. On the one side, I'm going to type sine 75 degrees in my calculator, but to save some space, I'm not going to write it out. Just sine 75 degrees. If you're doing that with me on your calculator, you should get about a 0.965 or so. And I'm going to multiply that by 5. All right. So on the one cross, if you multiply those out, you should end up getting a 4.83 approximately. And on the other side, crossing the other side, that's going to give you a 7 times sine of S. At this point, we want to get rid of 7 so that we get just sine of S by itself. So we'll divide this on both sides by 7. Dividing that by 7 on my calculator, I get a 0.6899. I'll go ahead and write that out. 0.6899 is equal to sine of S. If you remember back from section 8.3, if you're, we can do some inverse trig. If you're not familiar with inverse trig, check back to section 8.3. We can do sine inverse. That's the sine with a -1 attached on both sides. Sine with a little -1, sine inverse on both sides. On the one side, that's going to leave us with just angle S, the measure of angle S. And on the other side, I can go ahead and do the sine inverse of that decimal on the calculator, and that gives me a 43.6 degrees. 43.6 degrees. As always, ask yourself, is that a reasonable answer? Well, 43.6 degrees, looking at angle S, it looks like it's about half of a 90-degree angle. A 90-degree angle would look something like this. Looks like it's about half of a 90-degree angle. Half 90 is 45. 43, pretty darn close to 45. That seems pretty reasonable to me. For this last problem here, we're going to go back to that classic problem of finding out how high an airplane is up in the air given a couple of distances. Here we have two people observing a plane. One person is at location A, one person is at location B. We have a plane that's flown and it is currently over here with a couple of wonderfully drawn wings on either side. And in this plane, we see that the first person sees that it's at a 43-degree angle. Second person sees that it's at about a 67-degree angle of elevation. In the end, we want to know how tall this plane is up in the air, how high this plane is up in the air. Here's what we can do. We're going to start by solving for this side, right here. We want to solve for this side. We don't know how big it is yet. However, we could do some trig. We can figure out that this angle here, 67 degrees, this other angle has to be 180 minus 67. I'll write that up here. 180 minus 67 is going to give us 113, right? 113 degrees? Yep. 180 minus 67 gives us 113. We know that that angle is 113 degrees. I can go ahead and write that right here. In that case, we know then that this angle on top between these three angles, the 43 degree angle, the 113 degree angle, and this top angle all need to add up to 180 together. So 180 minus a 113 minus a 43 degree angle is going to leave us with 24 degrees on the top. 24 degrees. If we want to know this missing side, I can call this side lowercase a because it is opposite angle A. Opposite angle A, lowercase a. I can go and write an equation like, let me write this up a little higher here, sine of 43 degrees over side A. We don't know how big that side is yet. That's going to be equal to this angle here, the 24 degree angle, over that 3 side. All right. I'm going to go ahead and write that out there. Sine of 24 over a 3 side. Shoot, I just erased everything. Let me bring it back here real quick. Sine of 24 over the 3 side on one part of the equation. And on the other part of the equation, I had sine of 43 over the A side. Here we go. Back up to normal. I'm going to go ahead and cross multiply and divide just like usual. I'm going to go ahead and type in 3 times sine 43 on my calculator. 3 sine 43 degrees. That's going to give us a 2.046. 2.046 is equal to sine of 24 times our A value. The sine of 24, I'm actually going to write that 2.046 sine of 24. I'll go and write that in, put that in my calculator. That gives us a 0.407 approximately, 0.407 A's. We can go and divide both sides like usual. Divide both sides by 0.407. Divide by 0.407. Those are going to cancel out, and we're going to be left with just an A value on one side equals, and dividing 2.046 divided by 0.407 gives us a 5.03 approximately, 5.03. This distance right here, 5.03. After we're done with that, we can go back to normal trig. We know this is going to be a 90-degree angle down here. We have an angle. We have the hypotenuse right up here. We want the opposite side. Opposite hypotenuse, going back to SOHCAHTOA. Opposite hypotenuse, we're going to go ahead and use our sine. And we can say then, let me use some better font here that you can actually see, sine of 67 degrees is going to be equal to our opposite side. We don't know. Let's go ahead and call that x over our adjacent side that we do know, 5.03. We'll cross multiply these. This is over a 1. On the one side we get an x, and on the other side we're going to get 5.03 times a sine of 67 degrees. That gives us a 4.63 miles up. Always ask yourself, does that seem reasonable? If this distance here on the bottom is a 3 miles, it seems pretty reasonable looking at this distance, that this distance would be a little over 3 miles, 4.63. It seems pretty reasonable, and if you ask yourself how tall that is, 5,000 feet for every mile, that's about 20,000 feet up in the air. It seems like when you fly a plane, they say something like, you've reached an elevation of 20,000 feet, cruising altitude, and blah, blah, blah. Seems pretty reasonable to me. As usual, email me if you have any questions. If you need that, that's on my Moodle page. I am reece@sbcpa.org. Or bring your questions into class. I'm here Tuesdays, Thursdays after school. Have a wonderful day. Assignment tonight, you're going to be working on your law of sines homework.